My name is FRISHMAN, and today I'm going to talk about the ethics of biotechnology. Biotechnology is a extremely diverse topic, and there are four subjects that I'm going to try and separate as much as I can to talk about the sciences and the ethics behind them. Stem cell research, genetic pharmacology, embryo screening, which is also known as gene therapy, and cloning. First, we're going to be talking about stem cell research. Stem cell research is a branch of biotechnology. As I said earlier, stem cells are taken from embryos. This is a picture of an embryo right here. And so, the big part about stem cells is that they go through this process called differentiation. Differentiation is when cells are directed to differentiate into a certain part of the body, as we'll show earlier, whether it be a bone or a cell or any kind of tissue. Either way, these stem cells, when they're 7 to 8 days old, that's when the process starts. So before then, they can literally become any part of the body that is needed, and that's what stem cell research looks to work upon and use as a benefactor. As I said, it looks for the generation of, our stem cells work for the generation of both cells and tissue of the body. And there's been success so far. Research on mice, as all the research starts out, show that bone marrow stromal cells transplanted into a heart of a damaged heart of a mouse can actually have beneficial effects. So it looks a lot at stem cell transferring, any cell transferring, and seeing how that can be a beneficiary on humans as well as mice and other animals. So a big part about stem cells is what they can treat. And this is a list. As you can see, this is what affects many people today. Heart disease, Alzheimer's, spinal cord injury, strokes, burns, diabetes, and arthritis could all potentially be, if not cured, very, very much helped and very close to being cured through this process. However, before stem cells can be a huge part of our society every day, they need to do a couple things with the research. One is that they need to become the desired cells. We don't know exactly how to control them yet to the point where we can control them to become the cells that we need them to be. Survive after the transplant, so once they're in your body, keep going and functioning as what we need them to be. Avoid harming the host, which obviously is very key, and integrate into the host so that it becomes a part of their working system and doesn't, as I said earlier, harm the host. The negatives around this revolve around abortion, the same kind of ethics that confront abortion every day, whether it's taking a life or not, and because fetuses and embryos are all taken, and obviously they cannot live if we're taking their stem cells. And so is that wrong of us to take this 8-cell embryo and kill it to help others? Is that correct? However, I think that this negative does not outweigh the good that can come from this, because I think everyone knows someone that has been affected by one of those diseases that I put up on the board, and therefore it would be key it would be really great if that could become part of the cure and help society and help us to find a way to beat these diseases. Next up, I'm going to talk about genetic pharmacology. Genetic pharmacology looks to target diseases on a much smaller molecular level than how we target diseases now. It looks at specific patients considering genetic makeups and DNA, and looks at a new level targeting disease. The most famous way of targeting, or most famous form of genetic pharmacology, comes with diabetes. It is, for those who don't know, it is not cured but treated by using insulin. However, how this insulin is produced is through actually a very simple but yet key form of genetic pharmacology, as well as it integrates with cloning a little bit. I'm going to try and separate it here. Insulin that we have is injected into E. coli, which is actually a naturally cloning bacteria, and by putting the E. coli in there, it can receive that insulin and store it and then when it is cloned, we can extract it and actually crystallize it and inject it into diabetic patients, therefore giving them the treatment they need. And that is, diabetes is being attacked on a much more genetic and molecular level than any disease we have commonly treated as diabetes right now. So we talk about how it kind of intertwines with DNA targeting, and so it looks at the damaged DNA in your body. That's what genetic pharmacology would do. It's quite literally its name. So by inserting healthy DNA into the corrupted DNA, as I said earlier, with the mouse and the stromal cells, it could actually look to help cure or fix genetic makeups and help us as a whole. Genetic pharmacology also combines a little bit with cloning here. By isolating molecules to be replicated, it can actually, by cloning and transfer the DNA or a healthy genetic makeup, you can, as I said, help those who need that and help cure them. Usually meds treat symptoms rather than the cause. And what genetic pharmacology also looks to do is to use this DNA trafficking and medical usage. It looks to target the causes and the actual disease itself rather than the symptoms, such as the headaches or the stomach aches. It actually looks to target where it is hurting you in your DNA system, where it's hurting you and where it's affecting your body, as opposed to how it is affecting your body. Also, the negatives of this is that it could advance us past the limits that we know now today as humans, which is very controversial, because is it our place in our lives to extend our knowledge or any part of our body past what we're given? So if these meds advance to the place where we're smarter, where we can take a pill and it makes us smarter, take it before a test because it's going to help your brain, or makes you more athletic. What happens if these pills can actually make you faster by getting DNA of someone that's fast, for example, and taking that and putting it into your body? Would that make you faster? And is that correct, morally correct of us? Overall, however, I see this as another good branch of biotechnology, because these are, I think, small negatives in a way that can help cure diseases. As I said earlier, we all know someone that has either their life is controlled by a disease, or they have died because of some disease that is uncurable or not really treatable at this point. And so by looking to do this, it would, I think, really change our society.